This is Algebra 1, Chapter 4.2, on pages 210 to 215. Many relationships in real life are linear. There can be a direct correlation between one thing and the second thing. If you look at the bike rider here, we can see that the time that he might practice his bicycle is going to be in a linear relationship to the number of calories that he burns. A linear equation in x and y is an equation that can be written in the form ax plus b equals c. And this would mean that a and b are not zeros, so they're actually not both zeros. And the solution of an equation with two variables is going to be an ordered pair that will make the equation true. So let's see how this would work out. So we're going to try to determine whether the ordered pair here, 1, 2, or 7 and negative 3, is a solution to my equation of x plus 2y equals 5. So I write the original equation down, and now I'm going to insert the 1 that's right up here for the x. So let me change. So I have 1 plus, hang on. So, and 1 replaces the x here, and 2y, the 2 goes where the y is, and now I just work out my equation. This is going to be 5 equals 5. So that is a true statement. So let's try the other one over here. Change fonts or colors. So over here I'll rewrite my original equation again. Don't know why it won't do a plus sign on this page, but okay. And we will insert the 7 for the x. If I get my plus sign to make right there. So I end up, when I put the 7 over here and the negative 3 right here, I have 7 plus 2 times negative 3 equals 5. If we work that out, we're going to have 7. It will not do a plus sign today. Plus negative 6 equals 5, and that will be 1 does not equal 5. So we would say that 7 and negative 3 are not solutions to the equation that we wrote up here. So let's look at my equation here. 2x plus y equals 1. I gave you 3 choices. A is an ordered pair of negative 3 and 7. B is 3 and negative 7. C is 1/2 and 0. And D is 5 over 2 and negative 6. So let's work through this and see how we would solve this problem. So on the first one, let's go with this one. I will write my original equation down, and we will put 2 times negative 3 plus, and that be 7 equals 1. I can work that. Negative 6 plus 7 equals 1, and 1 equals 1. So this statement up here appears to be true. So let's try a different one over here. So let's try rewrite my equation again. And 2 times 3 plus negative 7 equals 1. And we have 6 minus 7 is going to equal negative 1. So this one, is false. And now we will do C. So this one we have 2.5 plus 0 equals 1. I didn't rewrite my original equation, but you can tell. 2 times 1/2 is going to equal 2 over 2, which equals 1. So we would have 1 plus 0 equals 1. 1 equals 1. So C is true. And then we have 5. We'll have 2. Here, draw a line here. 2 times 5 over 2. And that's going to be on this first part of the equation. So this is going to equal 10 over 2, which equals 5. So our equation will end up being 5 minus 6 equals 1. And that is not a true statement, because this would actually end up being negative 1. Does not equal 1. So D up here is incorrect. Now we're going to try to find solutions of linear equations and figure out which ordered pairs would work. So our equation is negative 2x plus y equals negative 3. It's hard to tell if that's a negative there. So the first thing you do is write it out in function form, which is what we have here, but we'll rewrite it. Plus y equals negative 3. Okay, now we're going to add 2x to each side. So, and, screen won't work. P6. That was a negative 6 there, so we're left with y equals negative 3 plus 2x. Now we'll choose a value to substitute for x. The easiest x value is 0. So we'll do y equals negative 3. Oh, sorry, that one's not, didn't go there. Plus 2x. Let's see, now I want to put the 0 there. Okay. Okay, so now we have y equals negative 3 plus 2 times 0. And 2 times 0 is just 0, so y equals negative 3. So this ordered pair would be 0, negative 3, or on a chart, if you had x here and y here, the first ordered pair would be 1 and negative 3. And then you could continue trying out, you could go to 1 and you could go to 2. So let's see what happens when we do that. So let me erase this part if I can. Slowly, very slowly. Let's see if I can get a better eraser going here. Okay, so we'll go back up to our original equation, if I can. Let's see. I can't get rid of that 1, so hang on. And okay, well, I just got rid of that. Okay. Now we have, let's try the x as 1. And so we would have 2 times 1 plus y equals -3. Now, we can use what we had already worked out to where we had gotten down to what we were substituting. You don't have to go back and start all over. We can, because we already took the 2x off in the first step on that last problem, so we don't have to do anything there. So we can put in here, this time we can try 1. And now we can work this out. That would be -2 minus 3. So I went back to where we were because I was making it more confusing than it needed to be. So we're looking at this part of the equation right there. And all we have to do now in this case is just substitute the 1 in right there. So y equals -3 plus 2 times 1. Y equals -3 plus 2. And here y will equal -1. And so, let's see, this got erased here. Now we have 1 for x and -1 for y. And we could keep going all the way. We could do 2, and we would end up with 1. We could do 3, end up with 3. We would then could start on negatives. We could do -1 and -2. That would be the easiest way to do it, and you end up then with the ordered pairs of 0, 3, 1, and -1, and 2 and 1, and those would be the 3 solutions to our original problem. So it just asked for 3, so we could, once we had 3, then we could stop with 3. So the definition up here is the graphs of an equation in x and y is the set of all points x, comma, y that are solutions of the equation. The graph of a linear equation can be shown to be a straight line. So let's look at a table of values right here that were solutions to this equation here, y equals 3x minus 2. And here's the values, and now you just have to plot them. So we would have, the first set would be -2, -8, -1, and -5, 0, -2, 1 and 1, and 2 and 4. So you would literally just start graphing them. -2 and -2 and -8, let's just say, might be somewhere over here. -1 and -5, let's just say it might be like right there. 0 and -2, well, my graph's not here. Let me fix that other plot. I didn't have let's say the first one might be like right there. If I can get my pen to work. Maybe something like that. And then we have 1 and 1. And then we have 2 and 4. And so you're left with a line. And you draw your line through them like that, and this is the graph of x equals 3x minus 2. That's what that is, okay? Now, we have this equation here, and we got to get it in what's in function form, which means that we need to get, which is what we've been doing, we have to solve for y. So that's what we've been doing. The first step here is to add 2x to each side. So that will be plus 2x and x. I will rewrite my equation. That would be 4y equals 8 plus 2x. Now I'm going to divide each side by 4 so I can isolate my, and that will be y equals 8 over 4 plus 2 over 4x. Now I need to just simply simplify. That would be 1/2. That would be 2. Okay, let me re-say that this would be 2 right here plus 1/2 x. So we've now simplified this down as far as we can do. And now we can start adding in points from a chart. Let's say we already have a table charts like we just did before, and we have -4 and 0, -2 and 1, 0 and 2, 2 and 3, and 4 and 4. And now simply you can start plotting the points and do a graph. Again, it's going to come out something like, let's see, it would kind of look like that when you get done with it. And then you would say the graph of 4y minus 2x equals 8 is shown right here. And that's what we would be showing you. So let's just recap of what you do when you are graphing a linear equation. Step 1 is you rewrite the equation in function form. That's y equals. This is very important that you catch this. It's going to be y equals. Step 2, you choose a few values of x and make a table of values. Step 3, you plot the points from the table of values, and a line through these points is the graph of the equation. So here we have 2x minus y equals 7. I've rewritten the original equation. I can now subtract 2x from both sides. Minus, oh, I don't need that there, sorry. And we would have negative 2x over here. And that would leave us with negative y equals negative 2x plus 7. Now we're going to do something that I think is kind of big, because we don't want y to be negative. And so if we take and make y positive, then the opposite of y is the opposite of each term on the right side. So that means I change all my terms on this side, and I can do it that way. Okay? So you need to remember that to get rid of this negative, we take the opposite of everything. Everything becomes its opposite. In this equation, I have 6x plus 3y equals 18. Again, I want to get my 3y on this. I want to get my y on the side by itself. So I'm going to subtract 6x from both sides. That will give me 3y equals 18 minus 6x. Now I have to get rid of the 3 here, so I will divide both sides by 3. That will give me y equals 18 divided by 3 minus 6x divided by 3. And now I will have y will equal 6 plus negative 2x. That was an x there. Okay. And that is how we would do that one. We've simplified it here as far as we can do it, and that would be the answer. Here we have 4y equals 3x. Oh, what did I do there? It's supposed to be, 4y, oh, that's what I did wrong, sorry. 4y minus 3x equals negative 28. Now I'm going to add 3x to each side because I want to isolate my y. I will end up with 4y equals negative 28 plus 3x. And now I'm going to divide by 4. That will give me y equals, I'm going to rewrite this a little bit, 3x over 4 minus 28 over 4. And let's see, when we work that out, we end up with, when we simplify it as far as we can, we will have 3 over 4x minus, and that would be 7 there. And that would be the answer to that one. Now let's find 3 ordered pairs that are solutions of this equation. So let's see. I think the simplest thing would be is to try the values of 0. We might try negative 1 and 2. So let's see what that does. Y equals negative 2 times 0 plus 1. Y equals 0 plus 1. Y equals 1. So for 0, the answer is 1. So that would be 0, and I would write that 0, 1. If I have, if I try negative 1, let me see if I can erase this one right here. Okay, so now I'm going to try negative 1 here. That will be negative 2 plus 1 is just negative, oh, sorry, I did that wrong. Hang on. Okay, so I had made a error here. We had negative 2 minus negative, or times negative 1, which would make that plus 2. And that would equal 3 there, not 1. And then our coordinate here would be, for this one, we would end up with negative 1 and 3. Sorry about that if I confused you. I had a phone call there in the middle of this. So now we're going to try the value of 2 here. And we have negative 2 times 2 plus 1. So we can work that out. That means y equals negative 3. And so our coordinates would be 2 and negative 3. And if we were plotting them on, or recording them on here, we would have 2 and negative 3. So the first thing we have to do with this problem, x minus y equals 7, is to try to get it, rewrite it in function form. So we need to get the y, so we're going to subtract x from both sides. That will give us negative y equals negative x plus 7. Now we don't want the negative here, so we're going to do the opposite of the opposite, just opposite, so we change everything to a different, and that would make this a negative here, there, although I don't really want it down there. I want it right there. Oh well, it's just not going to behave. So now we have y equals x minus 7. And we could try, okay, so I have some chicken nuggets here, and my dog is going crazy. He's sticking his nose right up here. That's what the panting sound is. Now, if we were going to try some values, let's say we could try 0, negative 1, 1. And you get that we're just kind of trying different ones from negative 3, negative 2, negative 1, 0 to positive 1, positive 2, positive 3. I don't think you have to go much higher in any of the solutions that we're talking about at the moment and throwing in a negative. So I went ahead and worked ahead a little bit on this problem. We have y equals x minus 7 because we did the opposite to get this to be a positive. Then I plug in my negative 1 number. I just decided, start with that. Negative 1 minus 7, and that's going to be y equals negative 8, and my coordinates then will be the negative 1 and the y of negative 8. I could go through and plug each one of these numbers in and do the same thing. Then I could plot them on my graph and see which way the line would go, and this one would end up looking something like that. Now actually it wouldn't look like that at all. Hang on. It would look like this was my halfway mark. I think it would be, it wouldn't even go up to there. Sorry. My stylus does not want to, it would look something like that right there. Okay, this is Algebra 1 4.2 assignment. It's found on page 213 to 215. You're to do exercises 18, 19, 25 through 27, 34 through 36, 60, 61, 64, 67, 74, and 77. Now, in this green box, I have another set of lessons. This is 43 for 44, 52, 53, 57 through 59, 62, 63, and 70 through 75. I'm splitting this lesson up, but I have to match it up with your blue days, so you'll have to ask me about this when we make the assignment. I think depending on which day is your blue day, so I'll help you with this when you get to this point. Okay, so we have 4x plus y equals negative 2. We're going to try to use 2 as a solution, as a value, and we have 4 times 2 plus y equals negative 3. We can work that out a bit. That would give us 8 plus y equals negative 3.